differentiate. So in part A, we got y equals 5 cotangent of some function of theta. We know that derivative of cotangent, say theta, with respect to theta is negative cosecant square theta. But if we have not only theta, we have a function of theta, then we can always say, okay, cotangent of u, and when we find its derivative, that's again cosecant square of u, but at this time from the chain rule we need to multiply by u prime. So I'm going to apply this formula for part A. This 5 is just there, so y prime is 5 is just 5 times, using this, times a negative cosecant square 3 theta, that's like u, times derivative of 3 theta with respect to theta, that's 3. That's it. We can simplify this negative at the front. 5 times 3, 15 cosecant square 3 theta final. Okay, so let me do part B. So we got secant square tangent x. So we can rewrite this square is in fact secant of tangent x, and square, everything is square. Now we can think inside function as u, so this becomes u squared, and we know the derivative of u squared, that's 2u with respect to u, but when u is a function of other, then we multiply by u prime. So I'm going to apply this formula here to find the derivative of this. So f prime is 2u times u prime, and we are not done because we need to find the derivative here, and u happens to be secant of tangent x, secant of tangent x. Okay, so let me erase this now. Okay, there is nothing, so I can write just 2 secant of tangent x times, so here is secant of some angle prime, so secant, and we know the derivative of secant, right? When we have secant of x alone, derivative is just secant x tangent x. But when we have a function of x, not x, we have, let's say, u, then this is secant u tangent u times just derivative of u. U is inner function, so secant u, this is like u. I'm going to apply that formula, and that gives me secant tangent, secant u times tangent u times u prime, means derivative of tangent. So let me write one step extra. Or we know derivative of tangent x, that's just secant square x. This is tangent, this is not tangent square, by the way. This tangent x as an angle. So this one, let me write just here so that we can finish this one. I didn't have to write derivative of secant x, so we could have written just secant square x. Okay, when we have derivative of inside, that's just secant square. Let me match the color. This is final. I mean, you cannot multiply anything, but if we simplify, which is optional, this looks simpler, so let me put here secant square x, and I can see same thing here, secant of tangent. It's like x times x is x squared, so we can write secant of tangent x squared, and we have tradition to write square here, or you don't have to write this if you don't like. And here is tangent of tangent x final.